Okay, welcome to the test recording of literature passage number 5. Let's look at the passage. An example of a scientist who could measure without instruments is Enrico Fermi, a physicist who won the Nobel Prize in Physics in 1938. He had a well-developed knack for intuitive, even casual-sounding measurements. One renowned example of his measurement skill was demonstrated at the first detonation of the atom bomb, the Trinity test site on July 16, 1945, where he was one of the atomic scientists observing from base camp. While final adjustments were being made to the instruments used to measure the yield of the blast, Fermi was making confetti out of paper, out of a page of a notebook paper. As the wind from the initial blast wave began to blow through the camp, he slowly dribbled the confetti into the air, observing how far back it was scattered by the blast. Taking the farthest scattered pieces as being the peak of the pressure wave, Fermi concluded that the yield must be greater than 10 kilotons. Now, this is just a way in which we are hashing our argument. The argument was not the argument, but the description was that one of the scientists who could measure without instruments is Enrico Fermi. And this is just the story of him, demonstrating that skill to us. This would have been news since other initial observers of the blast did not know the lower limit. After much analysis of the instruments reading, the final yield was determined to be 18.6 kilotons. Like Eratosthenes, Fermi was aware of a rule relating to one simple observation, the scattering of confetti in the wind, to a quantity he wanted to measure. The value of quick estimates was something Fermi was familiar with throughout his career. He was famous for teaching his students skills at approximation of fanciful sounding quantities that at first glance they might presume they knew nothing about. That means without knowing anything about it also, you can make an educated guess about something that is there. The best known example of such a Fermi question was that Fermi asking his students to estimate the number of piano tuners in Chicago when no one knows the answer. His students, science and engineering majors, would begin by saying that they could not possibly know anything about such a quantity. Of course, some solutions would be to simply do a count of every piano tuner, perhaps by looking up advertisements, checking with the licensing agency of some sort, and so on. So they came up with some kind of logical answers for his question. Okay. But Fermi was trying to teach his students how to solve a problem where the ability to confirm the results would not be so easy. He wanted them to figure out that they already knew something about the quantity question. So basically, even without knowing anything, he wanted them to understand that they knew something about this, case, and with intuition, they can bring out the answer. All right. Okay. So if we look at the first question, suppose you apply the same logic as Fermi applied to confetti. Which of the following statements would be the most appropriate? You can calculate the minimum pressure inside the cooker by calculating the maximum distance traveled by any of its parts after it explodes. You can calculate the average potency of a firecracker by calculating distance covered by one of its bigger fragments. You can easily figure out the average potency of an earthquake by measuring the length of crack it makes. You can calculate the exact volume of water stored in a tank by measuring the distance covered by the stream of water. Wow. Okay. All right. So if we were to look at this objectively, only statement A makes sense to me because the reason is there's a cooker over here, okay, which is giving out some pressure. Now this is my pressure cooker, okay. And what's he saying? He's saying that you can calculate the minimum pressure inside the cooker by calculating the maximum distance traveled by any of the parts after it explodes. Okay, the same logic as what's given in the blast. When you're talking about this average potency of a firecracker, okay, average potency of the fragments, we don't know about the potency. Potency is the strength. Okay, so in this part, we have not talked about the potency because we have talked about the pressure wave. So although most of these sound correct, Okay, although most of these sound correct scientifically, he's talked about pressure, and that's all we can relate to the answer. We can't talk about something that's not given in the passage at all. Okay, so these three would become out of scope choices. This is the only choice that would make sense.